In the previous video, I went over the 3 key properties that you have to be able to work with, understand and recall when you're working with scalar products. That is them being communicative, associative, and if a dot b equals 0, the two vectors are perpendicular to one another. In this one, I'm going to set you a few questions on them. I want you to pause the video, read the questions, have a crack at them, and then come back and check your answer with the working that's presented here. So, here they are. First one, I've given you 3 vectors and I want you to find s dot bracket u plus v and u dot bracket s minus 2v, so using those sorts of properties there. Second one, I'm telling you if p dot q equals p dot r and neither of the 3 vectors are 0, I want to know which of the 3 statements I've written down there are true. Are they all true? Are they all false? Or is there a mixture? You have to use your brain and interpret that. And the last one, I've given you a figure with 4 vectors in it and a few angles and a couple of the magnitudes for these vectors. I want you to find p dot bracket q plus r plus s. So this time the bracket's got more than just 2 vectors in it. So, pause the video and have a go. So the first one, I've given you 3 vectors, s, u and v, and I want you to calculate the 2 scalar products given here. Now both of these have a bracket with a combination of vectors in it. So this is the one where we have to use the fact that the vectors are associative, i.e. it's like multiplying them out as a set of brackets. So if we had 2 bracket x plus 1, it's using crab claw and multiplying them out. This time though, it's just with the scalar product. So for A, s dot u plus v is the same as doing s dot u plus s dot v. That was the associative property we were able to find out. The s dot u plus s dot v is the equivalent of this. So now it's just doing the 2 parts on their own. So s dot u is the scalar product of these 2 vectors. So in this case that would be 1 times negative 2 plus 2 times 0 plus 0 times negative 1. So there's our s dot u, our scalar product of s and u. We're then going to add on the scalar product of s and v. So that's the scalar product of these 2 vectors. So that's 1 times 3 plus 2 times 2 plus 0 times negative 1. So we do each of these on their own, combine them both by adding them. 1 times negative 2 is negative 2. Both of these are products with 0 in them, so they both disappear. So the s dot u just simply becomes negative 2. This one here, we do each of the parts on their own. 1 times 3 is 3, plus 2 times 2 is 4. And then this last one here, again, is a product with 0. 0 times negative 1 gives you 0. So we end up getting that. So it's negative 2 plus 3 plus 4. So that's negative 2 plus 7. It's 5. So s dot bracket u plus v is given by 5 in this case. What we can then do is do the second one. So for b, so it's u dot bracket s minus 2v. Again, we stick with that associative property. And we're going to do u dot s, take away 2v dot s. So take away the scalar product of these. Now, I've written this way because remember, the communicative property means I can swap them around. This one here, the u dot s, remember that is also the equivalent of s dot u. Well, I've done s dot u in the first one. I got negative 2. So I know that this part here is going to be negative 2. It's then this bit here that I need to do. Now, I could swap them and do s dot 2v, but it's s dot v I've done in the first part, not 2v. So what I'm going to have to do is scalar product of s with 2v. So I'm going to multiply this vector by 2 and then take it as the scalar product of that. So it's going to be my my s vector, which is 1, 2, 0, taken with double this vector. So it's 6, 4, and negative 2. We then do our scalar product, so 1 times 6 plus 2 times 4 plus 0 times negative 2. 1 times 6 is 6, 2 4s are 8, and that's 0, so it's 6 plus 8, which is just 14. A nice thing to notice here then is that 14 is double what we would get of the s dot v. So this was given us 7. So from the first part, we know that s dot v equals 7. We know here that s dot 2v equals 14. So what this allows me to do is actually generalize and say, actually, there's a nice new cheeky property. That's just double what I had before. So s dot 2v was the equivalent of doing 2 times the scalar product of s and v. So what that then allows me to do is kind of generalize that. So if I had s dot 3v, I could just take my s dot v and multiply it by 3. That's a nice new property for us to notice. So the second part of the calculation is 14. So for this one, it's my first part, the s dot u, which is 2, take away the 14. It's negative 2 minus 14, negative 60. So there you go, that's the first question done. Second one, if p dot q equals p dot r, and neither p, q, and r are 0 vectors, which of the following are true? So I've got to do each of these on their own. So let's look at A first. So p dot q minus r. Now the ultimate goal is p dot q minus r equals 0. Is that true? Well, let's use the associative property and multiply out the bracket. We know then that's p dot q take away p dot r. Now, two different sets of vectors. How can we do that? Well, let's look back at the question. We know that p dot q equals p dot r. So I can substitute in here. And I can say, well, that's the equivalent then of doing p dot r take away p dot r. So it's the same thing, subtracting from each other, so it's 0. This one's true. So part A, question A, is true. It works. What I now want to do is look at B. So B says Q equals R. So that's what I want to do. I want to show that Q equals R. If it does, then B is true. Well, let's look at the initial property, that P dot Q equals P dot R. We're told that at the start. Now, P is going to be the same vector in both, regardless. What that means is any change between them comes from this second vector. That's where any change comes. But we know they are equivalent. So for them to be equivalent, that second vector also has to be equivalent. Therefore, Q has to equal R. So Q has to equal R, therefore it's true. Property B is true as well. Last one we want is to show P is perpendicular to Q minus R. P is perpendicular to Q minus R, this third one is true. Now remember, for two vectors to be perpendicular, A dot B has to equal 0. So we want to know if this, with the scalar product of this, is equal to 0, i.e. does P dot Q minus R equals 0? Well, does it? Yes. The first property was true, P dot bracket Q minus R equals 0, so we can just take that and use it here. We've proven it's true, so we've not got to worry about that at all. We can just take it as being true. We know P dot Q minus R equals 0. That's correct. A dot B is equal to 0. Therefore, they're perpendicular. So that third property is true as well. We have to understand all these little intricacies when it comes to vectors. All these little bits when we're working with scalar products and all the properties we can use together. The last one, in this figure, magnitude of S is 6, magnitude of Q is 3, magnitude of P is 3 root 3, and the magnitude of R is 4. They're given in this diagram here. I want to find P dot Q plus R plus S. Now again, this one is going to be coming back to our associative property. We want to multiply out this bracket. We'll have 3 scalar products to work with. We then just take it from there. So what we want to do is then P dot Q plus P dot R plus P dot S. Now, we've got each of these scalar products, but we don't have vectors. We're not given a full vector, so we can't do them straight away. But what we have to remember is we've got a second version we can use. The A dot B equals the magnitude of A times the magnitude of B cos theta, where theta is the angle between them. So we can do each of these using this formula and then substitute them back in. So let's start with the P dot Q. We know that for P dot Q, it's going to be the magnitude of P times the magnitude of Q times the cosine of the angle between the two vectors. Now we're told what the magnitude of P is. That's 3 root 3. We're told what the magnitude of Q is. That's 3. We also know what the angle is. Look at the diagram. There's P, there's Q. The angle between them is 30. So we're after cos of 30 degrees. So 3 root 3 times 3, that gives me 9 root 3. Cosine 30 degrees, think back to your exact values triangle. Again, sometimes it's helpful for you to draw. There's your 30, your 60, root 3, 1 and 2. Cos of 30 is root 3 over 2. So it's times root 3 over 2. So 9 times root 3, well, the two root 3's together give you 3. 9 3's are 27. It's 27 over 2. There's our P dot Q. Next we want to do the P dot R. And again, it's the exact same thing. The only difference is this is an R and it's the angle between those two. So it's the magnitude of P, magnitude of R, cos theta. Put in all the parts. Well, we know the magnitude of P is 3 root 3. Magnitude of R, it's up here, is 4. And then it's times the cosine of the angle between them. Well, you've got to look at the two vectors. It's P and R, so it's this bit here. So it's 60. It's the full angle part here. So it's times cos of 60. So 3 root 3 times 4 times cos 60. That gives me 12 root 3 times the cosine of 60, which is a half. What that then gives me is 6 root 3 is my answer there. Last one we then have is the P dot S. Again, same formula. The only big difference is it's the magnitude of S there, and the theta is the angle between the P and the S this time. So magnitude of P, again, we know is 3 root 3. The magnitude of S is 6. And cos theta is times the cosine, this time between P and S, of 30. So 3 root 3 times 6 gives me 18 root 3. Cos 30, we know from up here, is root 3 over 2. So in this case, 18 times root 3, that becomes 3. 18 divided by 2 is 9. 3 9s are 27. So I've got all three parts now. Now it's a case of combining them in here. So P dot Q is 27 over 2. P dot R is 6 root 3. And P dot S is 27. Put it all together and get it over a common denominator. I've got 27 plus 12 root 3 plus 2 27s, which is 54, all over 2. Simplify it as much as we can. 54 plus 27 gives you 81 plus 12 root 3 over 2. There we go. We've got what we want as a final answer. You could factorise the top if you wanted. Take it a common factor of 3. And you would end up having, well, 81 divided by 3 gives you 27. Plus 4 root 3 all over 2. So you could also write it in that version there, that variation of it, by taking out the common factor. We have to remember all three of these properties. They have to come naturally to us. They have to come as instinct off the top of our head, so that when we get questions like this, we instantly know which ones to apply, which ones to use, and how to go about doing them.